Okay, good morning, everyone. Okay, Sen, I think we are good to start.
Okay, good morning, everyone. My name is Senne, and I'm a student teacher from Belgium. And today I would like to teach a class to you about quadratic functions. So I'm very happy to be here, and I hope that everyone will enjoy themselves. So if you have any questions during the class, you can ask them in the chat, or you can ask your teacher, Stephen Kaziba, to come to the front of the class and to ask your question. But I will now start sharing my slides. Okay, so are my slides visible right now? Can everyone see the slides?
Yes, they are visible.
Yes, they're visible. Okay. So what will we do today? There are three big learning outcomes that we want to focus on. So first of all, we want to discuss how you can find the quadratic function if you know its roots and one extra point that lies on the parabola. We want to solve simultaneous equations if you have one quadratic equation and one equation of the form y is just a number. And finally, we want to find parabola in our everyday life. So everywhere around you, you can find parabola. We're also going to do some exercises on that. So first, let's start with some recapitulation of what quadratic functions are. So a quadratic function is a function of this general form. So y equals ax squared plus bx plus c, where a is not equal to 0. Now, what does the graph of a quadratic function look like? And for that, I have a little exercise for you. So everyone who's sitting behind the computer right now, what you can try to do is use the annotation function of Zoom to try to draw the parabola. So I don't know if you know how it works, but you can press in the lower left corner on the pencil, and then you can draw on the screen. So please try to draw the graph of a quadratic function on these things. The pencil is down here.
Yes. Sen, what is the instruction?
So press the pencil in the lower left corner to make annotations on the screen, and then draw the quadratic function, draw the graph of the quadratic function. These corner systems. Okay, I already see one example. Very good. Thank you, Rama. Has an example as well. Okay, Sydney 2. Very good, very good. Anyone else wants to try? So this is indeed one kind of a graph, but there also exists a graph which looks completely different. Maybe someone else can try to draw that. Now you have something that looks like a mountain, but you can also have something else. Yes. So Rama has drawn the second one. Indeed, you have can also have an upper point in parabola. So thank you, everyone. So indeed, let me maybe quickly, can I remove the annotations maybe? Wait, how to remove the annotations? Here, it's now in the right lower corner. Okay, sorry for that. So indeed, we have two kinds of graphs. We have something which looks like this, an upper pointing parabola, and we have a lower pointing parabola, which kind of looks like a mountain. So as I said, these shapes we call parabola. Now, we want to study this parabola in a real-life example. So what is a problem that we will study today? So the problem that we will study, the government wants to build a tunnel in order to transport food throughout the country. This tunnel, it has a parabolic shape, as you can see here. It is 15 meters high in the middle and 20 meters wide. Furthermore, you have a delivery truck, like you can see down here, which is 3 meters high and 2 meters wide. Now, the question is, how many trucks can drive through the tunnel at the same time, side by side? So you have a tunnel, 20 meters wide, 50 meters high. You have a truck, 2 meters wide, 3 meters high. How many of them can drive through the tunnel at the same time? And to get acquainted with the problem, before we start with the mathematics, I've made a little applet for you all. So what will we do? I will share a link in the chat in a bit. You will press the link, and then you press continue without signing in. If you do that, then they will ask you to write down your names. And then I want you to write down all the names of your group members. So everyone who works together on one computer, please write down your names there. So I will share the link now in chat. Chat. So there should be a link now. So please click on that. And then press sign in. Continue without signing in, and then write down all your names. Okay, I see some names already. Okay, 4, 5, 6, 7. Maybe some more people want to join. So press the link, continue without signing in, and then write down all your names. Yes, another one. Okay, so what can you see here? As you can see, you have a parabolic shape on your screen. The brown rectangle, that is the ground. The blue area, that represents the edge. The white part represents the tunnel. And the black rectangles, they represent the trucks. So what I want you to do is, using your mouse, you can drag the trucks. And I want you to try to put as many trucks as possible into the tunnel. But keep in mind, a truck cannot go into the ground. It cannot go into the wall of the tunnel. And they can also not overlap. So how many trucks can you fit in the tunnel? I will give you some time to do that. think most students are finished. I will wait a little while longer for everyone to finish. Okay, good. So let me share this screen. So now normally you should see my internet browser. So as you can see, most of you have already managed to do it. So let me, for example, look at this student's answers. So as you can see, this student was able to put in 8 different tracks into the tunnel. Here it goes a little bit outside, but if we move this just a bit to the left, then you see it can completely fit in. So 8 is indeed the correct answer. If you look, then most people here, they as well got 8. So very good of you. When I tried this at home to test it, then not everyone got 8. So it's very good that you managed to get 8. Good. Then I want to share my slides again. So 8 is our answer. 8 tracks can fit into the tunnel at the same time. I quickly need to pause the lesson again, otherwise you maybe will not listen. So 8 is the right answer, but now the question is, how can we prove this mathematically? So we know it from the little experiment with trial and error that it is indeed 8, but how can we prove this? And in order to do that, we need to go through 3 different steps. So what I want you to do now is try to think in small groups for a very short time. What do we have to do mathematically to solve this problem? So now I want you to think for a little while, how can we solve this problem mathematically? What do we have to do? You don't need to do it, you just need to tell me what we have to do. So maybe you get 1 minute or something to discuss it with your neighbor. Yes, Daniela. I already see an answer. Divide the length of the parabola by the length of the tracks, then round to a whole number. So with the length of the parabola, do you mean this length? So the arc length. So, or do you mean something else, Keith? And everyone else, if you have an answer, then please share it in chat. The base length. Yes, so if you share the base length, then that's this one. Then you have a problem because the shape, it's an arc. So that means that although you have maybe 20 meters here, at the top, you have less space. So it's not the base length that we have to discuss, but indeed we have to discuss such a length divided by the length of a track and then round it to a whole number. And it's important to round down. So, but before we can do that, we have to do something else. You want to discuss the parabola, but at this point, we don't know what the parabola is yet. We have a tunnel, we have some measurements, but we don't know what the equation of the parabola is. So the very first step is we have to find the quadratic function of which the graph describes a parabola that is the roof of the tunnel. After we have found such a graph, like this, so we go from a real-life example to a graph, then indeed, like Keith said, we have to look at the distance at height 3, because the trucks are 3 meters high. So we have to look at the distance at height 3, and then interpret that result. So divide the length of this by the length of one track and then round down. So that is what we are going to do. So first of all, if you want to find the quadratic function, then we need to fix a coordinate system. Otherwise, if you don't have a coordinate system, then it's also not possible to describe it as a function or the graph of a function. So for this, I have a small exercise for you. As you can see here, I have the picture and I have 5 different points, A, B, C, D, and E. I want to use one of these points as the origin of a coordinate system. Try to think about it. Which of these points is best suited as the origin of a coordinate system? You can please write your answer in chat. So A, B, C, D, or E. What would be the best suited? People say A. So anyone else wants to try? A lot of people say A. Maybe some more people. Another A. Okay, I think we agree. Indeed, it is A. But why is it A? Well, if we use B or D, yeah, then we don't know how high we are. These are just random points. I did not say how high they are, so it's not logical to take B or D. If we would take E, yeah, then what would happen? Normally, if you draw axes like this, you would take the positive side to the right. But if we take the positive side to the right in point E, then that means that all the points of our parabola have negative x values. And that's maybe a bit weird to work with if you want to interpret it. And then finally, if we take point C, then we have the same problem, but now for the y values. Then all the y values are negative. So indeed, we take point A with a horizontal x-axis and a vertical y-axis. So in general, what kind of tips can I give you? If you want to choose an origin and coordinate axis to describe a parabola, then first of all, make sure that 0 is a 0 value, which means that you have to take your origin on the parabola. That makes things much more easier. And then finally, I advise you that you work as much as possible with positive values. Because this is way more easy to interpret the result at the end. It's not really necessary. If you take any point, you can do it, but the calculations become more difficult and the interpretation becomes more difficult. So I advise that you always look for positive values. Good. Now, another question for you. So please answer in chat. What are the 0 values of this quadratic function? So we know that it's 50 meters high and 20 meters wide, and this is our parabola. Then what would be the 0 values? There are 2 possible answers. Does anyone know what the 0 values are? So what are the 0 values or the roots? It's another word for it, for this parabola. So it goes like this. Are coming right now. So the 0 values are the x-coordinates of your intersection points of your parabola with the horizontal axis. So here we have 2 intersection points. Aha, what's a 0 value? Good that you asked. So a 0 value is the x value of your intersection points with the horizontal axis. So maybe you know it as the root of a quadratic function. That's another word for it. So 0 values or roots. So in this case, we have that this is an intersection point and this is an intersection point. So what would be the x value of this point here? 20, 0, that's a good answer for this point. So indeed, 20 is one of the zero values. So a zero value, it's if 20, 0 is your intersection point, then 20 is called a zero value or a root. I will try to use root as much as possible to not confuse you. And then the other one, that's just the origin. So we can just take 0. So the zero values are 0, namely the zero value of this point, and then 20, the zero value of this point. Now, remember that in general, we can write a quadratic function using this expression. So A, R1, and R2 are numbers that we need to determine. If we know these numbers, then we know what the quadratic function is. Question for you, which of these numbers do we know already? So do we already know A? Do we already know R1? Or do we already know R2? Maybe it's too difficult of a question, but I want to let you think first before I give another hint. So which of these do we already know? And why? Okay, so if you can, R1 is 0. Yes, that's very good. R1 is 0. That's something we know. Do we also know what R2 is? Or R1 is 20? Yes. So one of them, indeed, one of the R's is 0 and the other R is 20. How do we know this? If we would plug in R1 or R2, that means we get Y 0. So if you plug in R1 here, you get A times 0 times this, which is 0. If you plug in 20, and R2 is 20, then you get A times this times 0, which is 0. So R1 and R2 are precisely your 0 values or your roots. That's why we use R. So indeed, in this case, the roots are 0 and 20. So we get this. Minus 0, we don't have to write the 0. So we can write it as this. And then by using algebra, we can expand this to get this expression. So we almost completely know the quadratic function already by just knowing what your roots are. By knowing what your roots are, you know what your quadratic function is up to one parameter, one letter A. If we would know the letter A, what that number would be, then we have our quadratic function. So then, how can we find this value of A? Well, looking at the time, I will go a bit quicker and I will just tell you. So what we've already used is we already used that we have the roots here. So we already used that this is 20 meters wide. But what we have not used yet is that the parabola is 50 meters high. That's a given that we have not used, but is important for the shape of our parabola. So what we have to do is we have to choose another point of our parabola that we have not used yet and just plug it in. So in this case, we know that the parabola or the tunnel is 15 meters high in the middle. 50 meters high in the middle, that means the middle corresponds to 10 meters. There it's 15 meters high. So the coordinates are xy is 10, 15. This point also lies on your parabola. And now a small exercise for you. So x is 10, y is 15. That point size on the parabola. So what I want you to do is plug in these numbers in your expression of your function and use that to find a. So plug in the numbers and then try to find a. So I will give you a little while for that, and then we will continue. So what is a? So maybe I advise that you use a sheet of paper or something to try to work this out. Doing this in your head, it's not that easy. And if you find the answer, then you can type it in chat. Okay, so one answer already. Okay, I'm going to give the rest some time as well to find an answer too. Okay, another answer. Wait for one more. Maybe just one more. Feel like answers are coming in right now, so. Okay, so the answer is indeed minus 0.15. So how can we find this? Let's go over the solution. So if we plug in y is 15 and x is equal to 10, then we get this expression. 10 to the power 2 is 100. 10 times 20 is 200. So we get this. So that means that 15 is equals to minus 100 times a. So if we divide both sides by minus 100, we get a is equal to minus 15 over 100 or minus 3 over 20. So indeed, minus 0.15, that's another way to write this. So that's the good answer. Very good. So if we would plug that back into our quadratic function, then remember, our quadratic function was ax squared minus 20ax. So we now just replace the a by minus 3 over 20. Then we get this. And the final part you can simplify. Minus 20 times minus 3 over 20. That's equal to plus 3. So we were able to find our quadratic function, minus 3 over 20, or minus 0.15 x squared, plus 3x. So that's already very good. Now, in the next step, as we discussed before, we want to find the intersection points of our parabola and the horizontal line with equation y is 3. Why do we want to do that? A track is 3 meters high. So imagine if you have a track here in the middle and you move it to the left. The first point where it will actually leave the tunnel, where it will go into the wall of the tunnel, it is precisely the intersection point. So that's why we want to find the intersection points. That's where the track will leave the tunnel. So how will we do this? We have to solve a system of simultaneous equations. We have, on the one hand, the equation of the parabola, which is the first one. And on the other hand, the equation of the line, y is 3, which is this one. Now, question for you, how can we solve this system? So you can type it in chat, or maybe it's a good moment for someone to come to the front to tell me. Maybe that's also a fun thing to do. So how can we solve such a system? There are multiple ways to do this. Don't be afraid to give the wrong answer. If it's the wrong answer, then we can also learn from that. I don't know if someone is coming or not. Okay, if not, then let's just go over the answers. Wait, quickly, something wrong with my Zoom. Wait, give me one moment. Okay. Okay, now I can see you again. So what we can do is, you see y is equal to this expression here, and y is equal to 3 here. What we want to do is we want to find x and y for which both equations hold. How can we do this? We can try to eliminate the y. If y is equal to the first thing with the x's, and y is equal to 3, and if both equations hold, that also means that the first equation, minus 3 over 20x squared plus 3x, that should also be equal to 3. If this is y and this is y, then both of them should be equal to each other. This is what we called the elimination method. And if we do this, we get a quadratic equation. And we know how to solve quadratic equations, namely with the quadratic formula. So for a little bit of interaction, I've added another quiz question. So to solve a quadratic equation, we studied the quadratic formula. What is the quadratic formula again? Is it formula A, B, C, or D? Okay, I see that Stephen has taught you very well because everyone says D, and indeed D is the correct answer. So D is indeed the quadratic formula. With the quadratic formula, you can solve any quadratic equation, which means that we can also solve the quadratic equation that we found here. So again, a small exercise for you, and I will give you a little bit more time for this because it's longer than previously. How can you use the quadratic formula to solve this? So use the quadratic formula to solve this equation, and preferably write your solution in the following form. So an integer plus an integer times the square root of an integer that is a third. So it's not only an exercise on the quadratic formula, it's also a small exercise on thirds. So I will give you a few minutes for this, and then we will continue. If the second part is too difficult because it's too long ago that you used thirds, then just try to solve it, and then we can do the third thing together at the end. But try to solve the equation. What does the Z and the E symbol mean? Good question. So the Z symbol means the integers. So integers are the numbers 0, 1, 2, 3, 4, 5, 6, 7, etc. But also the negative numbers, -1, -2, -3, -4, etc. The E symbol means element of. So P, Q, and R are integers. That's what this expression means. So P, Q, and R are numbers of the form -2, -1, 0, 1, 2, 3, etc. That's all it means. It looks scary, I know, but nothing more than that. It's just nice integer numbers. But first and foremost, try to solve the quadratic equation, and then the second part comes after. I see one answer. Um, okay. Looking at the time, maybe we should continue now because I don't want to extend the class too long. So how can we solve this? Like I said, using the quadratic formula. But before we can do that, we have to rewrite the equation first in standard form. So now we have this equation, but in order to use the quadratic formula, recall, we have to set it equal to 0 and not equal to 3. So first, I will bring 3 to the other side, or even better, I will bring all these to the left side, because I like to start with a positive number because I'm a positive guy. So we put the right-hand side to the left by adding 3 over 20x squared and subtracting 3x, and we get this. And on this expression, we can use the quadratic formula. So the quadratic formula, everyone got it right earlier. So it's minus b plus or minus square root of b squared minus 4ac divided by 2a. I just plug in the numbers. So a is 3 over 20, b is minus 3, and c is equal to 3. If we just plug in the numbers, we get this. And then we start with computations. So first of all, 2 times 3 over 20, that's the same as 3 over 10. If we divide by a fraction, remember that means that we have to multiply with the inverse fraction. So dividing by 3 over 10 is the same as multiplying with 10 over 3. So that's what we're doing here. And then here we also computed this square and computed this product. We get 9 and 9 over 5. If we then continue the computation, we have to subtract these fractions. So we put them on the same denominator. And then we can subtract them by just doing 45 minus 9, we get 36. Then, and we also, what we've also done is we also did 10 over 3 times 3, and 10 over 3 times this square root. So that's what we have done here. And then we can simplify this fraction, namely by taking the square root of the numerator and the square root of the denominator. Square root of 36 is 6, so that means we get 60. And we get this, and then we can even simplify it a bit further by dividing 60 by 3, and then we get 20. So this is our result as an exact x value. However, this is not the result that I asked for. I asked for an integer plus an integer times a square root. Now, how can we go from this expression to an expression that looks like integer plus integer times square roots of an integer? Well, if we multiply a fraction with the same number in the numerator and the denominator, that means that we get the same fraction. So we can multiply numerator and denominator both by the square root of 5. If we do that, then we get the same numbers. Square root of 5 times square root of 5 is just 5. And then in the numerator, we get 20 square root of 5. And then 20 over 5, we can also compute that, that is 4. So our final answer is 10 plus or minus 4 times the square root of 5. So this is, these are 20 plus, yeah. So I think it will be, I actually did not come approximate it. So I don't know if it's correct, but while you're working on exercises, then I will try to approximate this, and I will let you know if 20.954 is correct. So the intersection points are indeed this, and then the height was 3, because y is 3 was the other equation. So these are our intersection points. 10 minus 4 times the square root of 5, 3. That is the leftmost intersection point. And then 10 plus 4 times the square root of 5, 3, which is the rightmost intersection point. So we have found the intersection points. That was the penultimate step. We only have to do one thing, and that is interpret results and answer the original question. So as Keith has already told us in the beginning, we have to look at the distance and then divide it by the amount of trucks, or by the length of a truck, better to say. So here we need to find the distance between these 2 points. So if we do that, we get here this L. We want to find the length L of this dotted line. If we do that, then how do we do this? We take the biggest x value here, and we subtract the lowest x value here. If we want to compute this distance in more generality, the formula is a bit more difficult, but because the y values are just 3, it's just the biggest number minus the smallest numbers. And if we do that, we get 8 times the square root of 5, which is approximately 17.89 meters. Remember, we are working in meters. Everything is in meters. Now that we know that the typical truck is 2 meters wide and 3 meters high, we can go back to the original question. How many trucks can maximally pass through the tunnel side by side at the same time? Does anyone know the answers? So the length, the available length is 17.89. Truck is 2 by 3 meters. How many trucks can pass through?
Have you a question?
Is there a question? Don't hear the question. But 8 indeed is the right result. So if there's a question, then you can come to the front or you can type it in chat. Okay, so 8 is the right question. 8 is the right answer. So indeed, maximally 8 trucks can pass through the tunnel side by side at the same time. So with that, we have answered our original question, and we are done with the problem. Now, finally, I have a small assessment for everyone. And for this, we're going to try something very new, something that I've not tried before, but I wonder what you think about it. We're going to try an online escape room. So before I share the escape room with you, let me first quickly show you how it works. Oh, okay, I will share my other screen now. Okay, so normally you should see the escape room right now. So what do I mean with an escape room? You're locked in this very cozy Easter-themed room. And the goal is to escape from the room by solving exercises on quadratic functions. How can you escape? If you click on certain objects, then an exercise will appear. Let me click, for example, on the door. If we click on the door, then we get a very special exercise. When you approach the door, you see a combination lock. To escape, you need to insert 5 numbers in the right order. So throughout the room, I've hidden 5 exercises. If you solve an exercise, you get 1 number. If you have all the numbers by solving all the exercises, then you can open this door. Now, how can you submit an answer? For example, imagine that you think the solution is 1, 2, 3, 4, 5, 6. Then you can just type it in these boxes. And after you've typed your solution, you can press this arrow at the bottom. If you do that, it will ask you to submit. Then you just type your name, and in your case, the names of all your group members, and you send it. Please use your name because that's the way that I can use to give you feedback. In this case, the feedback is that it was not the right code because we just guessed. We did not solve exercises to find the codes. So we have to try again. If you want to go back to the room to find other exercises, you have to press this arrow here. So if you press this arrow, then you go back to the room. So I will share the link now. And then you have to try to solve as many exercises as possible. I don't know if you have time to solve all of them, but just do your best to try to solve as many as you can. So here you go. So just press the link in chat, and then you should be able to go to the escape room and try to solve the exercises. So again, don't just click on the door. First, try to solve exercises which are hidden someplace else. I will share my PowerPoint again because there are some useful instructions there. But you can already start with the escape room. Good luck. If there are any questions, then don't hesitate to ask. Okay, can I please get everyone's attention for a little bit? So I don't know how much time there is left, but on my part, if you want, you can continue working at it. However, what I would also like to ask to you is if after you're done with the class, can you please fill in the following form? So I just sent a form in the chat, and in that form you can fill in some feedback on the use of the escape room. So it's the very first time that I used an escape room in order to use in a class. So I'm very eager to know what you guys think about. Let's fill it in now. Maybe that's a good idea indeed. Um, so this is the first time I ever used an escape room in a class, so I'm very eager to know what everyone thinks about it in order to know whether I should do this in the future or not. So if you want, then please click on the link, give your honest opinion. If you're working in groups, then please fill it in turns. So first person one goes and then person two, etc. So that would really help me out. And I don't know how much time there is after that, but if there's still time left in the class, then you can continue working on the escape room, or otherwise, yeah, the escape room will still be open. So if you want to escape, you can try it in a later class, maybe, or at home. Depends on what Steven wants to do.
I think let's first fill in the form.
Let's fill in the form. Okay. So please then fill in the form, and let me maybe stop sharing. Yeah, you can see me better. So good. Was a very fun class, I think. I hope you learned a lot. Wait, I can hear myself. Anyway, I would like to thank everyone for joining this class. It was very fun to do, and yeah, after you fill in the form, I hope you have a nice rest of your day and happy Easter. So I know there was not a lot of time maybe for the escape room, but you can continue with later if you want. Okay, so you can see it. There are 5 more minutes left. So if you have filled in the form, then you can uh, you can continue for 5 more minutes if you want. I will resend the form. There we go. Should be visible now. You see, I already got 8 responses, so very happy for that. Thanks a lot. It really helps me out.
Good afternoon, sir.
Good afternoon. Good afternoon. Okay, so I think that's all the time we have. So thanks a lot for joining and have a have a nice day. Have a nice afternoon. Have a nice day.
On behalf of the, the Grizzly class of 2025,
What did you say, Melissa? Okay.
that's what you want. On behalf of the Grizzlies class, we would like to say thank you so much for teaching us about quadratic graphs. It's a really interesting topic that we don't often get time to look into and understand. And we are extremely grateful that you were able to take a few minutes out of your day or an hour or two out of your day to teach us about it. Thank you so much.
Thanks a lot. I'm very grateful that I got the chance to teach you. It was very fun to do, and I hope you all learned something today. That would make my day if that would be the case. So yeah, thanks a lot.
Okay. Thank you so much, Senne, for the lesson. We shall be linking up at 1:30, and I'll be
Yes.
giving in my feedback. And I
Sounds
know
good.
by that time, I'll have cracked the code. So far,
We will
yeah,
see
so
if you're
far,
able to.
yes, this time around we shall have to crack it. I'll
Okay, okay.
let you know at 1:30.
Yes.
But thank you so much. Yes.
A pleasure. Thank you for giving me
Okay.
the chance. See you later then. Have a nice day,
Okay.
everyone.
Okay. Bye bye.